Harold here. Today I wanted to talk to you about window functions in polars. Let's get started. In the Colab notebook, I've installed polars. The -U will upgrade to the latest version. And import polars as PL from Rich. I'll import print, and I'm going to set my table columns and rows so we can see everything. 50 is enough. Uh, window function. We're going to create a data frame first to demonstrate the window functions. First, create a data frame. Um, Polars implicitly selects the data types when you create a data frame. If you want to set them explicitly from the start, declare a schema and use it as the second parameter in the pl.dataframe function. So I wanted to make a categorical out of the team here. Um, in the spirit of the Winter Olympics, if anybody remembers the Laugh Olympic cartoon, I'm going to use them for our database. So the schema is just brackets, name of the column, and data type explicitly declared. So name is a string, team is pl.categorical, score is int32, and rating is float64. Here's all my data frame data, and as you see, the second argument, I set the schema equal to schema. So we'll run that, run our df, and let's print our df. And there is our Laugh Olympics data frame. Um, Scooby Doobies, Yogi Yahooies, and the Really Rottens, their team members, their score, and their fan ratings. You see the team is categorical, where I implicitly see how the team name is categorical. That's how, because I explicitly declared that. See how the team name is categorical because we explicitly declared that in the schema. Okay, now on to ranking. Uh, I'm not going to type these as I go along. I'm going to let you guys take them out of the Colab notebook. I'll put it in the GitHub repo. I want you to pay more attention to the methods than just follow me typing on this one. So rank DF, we're going to rank everybody by score. So rank DF, we've done DF with columns. So we're going to do a pl.column score, and you say dot rank, and you can give it an alias. Then I'm going to sort score by score rank and print the rank DF. Rank defaults to ascending. Method defaults to average. I'll explain that in a second. So here is all of our competitors ranked by their scores. Ascending, the worst score, the lowest score, golf would be good, is the first. So that's how it shows. So that shows you that the default argument is ascending. And really, in ranking, you're going to use descending most of the time because you want the highest score. Average, Mumbly and Dinky Dalton were tied at 11, so it made them each 1.5 instead of first and second. Down here, these guys, you know, only had one at that. No, 3, 4, 5, 6, 7, 8, 9 only had one equal score, so they get their own. Then we have 236s for Huckleberry Hound and Quick Draw Then we have two 36s for Huckleberry Hound and Quick Draw McGraw. So they get 10.5. So that's the average. Now let me show you the other methods and descending. So we'll say now that our rank df equals df dot with columns, pl dot call score dot rank. Here we can add arguments. Descending equals true. Method equals ordinal. And again, we'll give it our alias and sorted by score rank. So ordinal, descending, you see now Speed Buggy and Shaggy at the top. Ordinal. Descending, you see now that Speed Buggy and Shaggy and Doggy Daddy are at the top with 42. So that is really ranking the highest score. And their score ranks are 1, 2, 3, 4, 5, just consecutive numbers. That is ordinal. It won't make any, whichever one it comes to first, it'll choose for 1, 2, or 3. It doesn't make any difference to it. It's going to take all the 42s and make one of them 1, one of them 2, and one of them 3. Um, you could say min. Min is what I would call dense. Min is what I would call skip. I guess Speed Buggy, Shaggy, and Doggy Daddy are all tied at number 1. And because there's 3 of them, they skip 2 and 3 and go to 4. So that's your min argument. Uh, there's a mac. So all the ones are not now ones. They're all third. They're all third. The top 3 scores are third. We've seen average, dense. Dense is going to give them all 3 ones, but still give Grape Ape a 2 because he had the second highest score, as opposed to that min, which was skip, which gave them all ones and made Grape Ape 4. And you can also do a random. And it's kind of like ordinal, but it just randomly selected which one it wanted to be 1, 2, and 3 from the first 3. Uh, if you want to do, say, partition or group by, and we introduce the over clause. So I want to do team rank. So within each team, I want to rank the members of that team by score. So team rank df equals df dot with columns pl dot call score dot rank descending equals true. I'm just going to use ordinal over. Here's where we go over. I want to rank them over their team. So group them by team and then rank them over that team. Give that an alias of score rank, sort it, team score ranking, descending of true or false, and then print it out. So let's run that cell. Um, so now within the Yogi Yahooies, Doggy Daddy was 1, Grape Ape was 2, Huckleberry Hound, and Quick Draw McGraw tied. It made them 3 and 4, and Yogi Bear was 5. So the over lets you, it's like partition by and SQL, group by, and then rank them over the group. Uh, there's a lot of aggregation methods. Here's some of them used to compare the individual to the group. And I just made a Stats is the df dot with columns. Rating is mean over team, min over team, max over team, and median over team. Will be average score, min score, max score, and median score. So for each team, it's going to repeat, but this is the average score for the Scooby Doobies. This is the minimum score for the Scooby Doobies. This is the maximum score for the Scooby Doobies, and the median score for the Scooby Doobies. And so on for the Really Rottens and the Yogi Yahooies. So that's a way to get to aggregate window functions. Now, some of the most useful window functions are running cumulative count totals and rolling or moving averages or totals. So let's get those. Running total. I'm going to do a running score over team. So I'm going to do running total by team. So running score equals df dot with columns, pl dot call score. We have these cum methods. I'm going to use sum for a running total, cum sum. There's also cum min, cum max, cum prod, and cum count. So let me show you. So cumulative sum over team, alias running total. Select name, team, score, and running total. So in the really rottens, 11 plus 17 is 28, plus 11 is 39, plus 19 is 58, plus 21 is 79. It's a running total by team. Now, let's look at the other ones real quick. So try Qmin. What Qmin does, it'll run through the team and get the minimum number it's run into up to that point. So Dynamite has 31, that's the minimum. Speed Buggy has 42, so Dynamite's still the minimum. Captain Caveman has 34, so Dynamite's still the minimum until Hong Kong Fooey has 23, and now he becomes the minimum, and that carries over for Shaggy, and so on and so forth. Q max is the same, except it'll be the maximum. So Dynamite was the max until it hit Speed Buggy, and then he was the max for the rest of the team. Prod, you could probably guess what that's going to do. Make a bunch of big numbers. At the cumulative product, 31, 1302, 4 whatever, 42 million when you get to Shaggy. And then just count, basically going to count them. This just like row number or ordinal. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's running your cum functions. There's an actual rolling function. Uh, so for rolling or moving, there is an actual function rolling. So I could say I want a 3 window rolling sum The ratings, I can say rolling 3 equals df dot with columns pl dot call rating. Rolling max, you need to tell it the window size as an argument to rolling max. Window size equals 3. Dot alias. So for rolling totals, averages, moving averages, there's actually a rolling function or a series of rolling functions, just like the cum ones. Uh, if I wanted a rolling sum of, so say I wanted the 3 window size rolling sum, 3 row rolling sum of the rating, I would say rolling 3 equals df dot with columns, pl dot call rating dot rolling underscore sum. And here you declare a window underscore size equals 3. And then I gave it the alias rolling sum rating and print rolling 3. So the first two are going to be null because there's nothing before them. There aren't enough windows before them. But then it'll start rolling the sum. 27.2 is 81, 95, and 96, so on down the line. So this is a rolling, this is the total of these 3, and so on down. And then the next one is the total of these 3, and so on and so forth. Not only do they have some, a lot of people do moving averages. So they've got mean. So my 3-day moving average was 9.06. My 3-window moving average was 9.06. We've got min. The 3-day, the minimum in that three window, the minimum in those 3 windows is 8.1, so on and so forth. Minimum in these 3 windows is 8.1. You could do max. Max in those 3 windows is 9.6. Uh, you got standard deviation, variance, median, quartile. I'll let you guys play with all those on your own. I think you get the idea. So that is window functions in Polar's data frames. I hope you liked this video. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody. Uh, hey, everybody. Harold here. Today I want to talk to you about struct and list data types in Polar's data frames. And I want to start with a struct, and many of you may never heard of a struct, or if you're from Rust background, you know exactly what a struct is. So df equals or go. So the data type struct is a composite data type. It can store multiple fields in a single column. When we build a series or data frame, Polars will convert dictionaries to the data type struct. So I got a dictionary here. So I'm going to create this data frame, df equals pl.dataframe. Soup is a list, so that's just the column name, just the name of the superhero. Their details are dictionaries. Spider-Man's real name is Peter Parker. He's 19. He slings a web. and his nemesis is the Green Goblin. So on for Captain America and Superman. So let's just print that. So it's a list of dictionaries. This will create a struct. So soup is just a string and the name. Details, it's a data type we haven't seen before, a struct with 4 fields in it. Name, age, power, and nemesis. Now, how do we handle those and access those values? There's 2 ways you can do that. You can access by field. So result equals df.select soup. And you could just want in one field, this would be the way to do it. This is the long way. I'll show you the easy way in a second. If you just wanted to access 1 or 2 fields, this is the way you would do it. Field.call details .struct.field name as name. And struct.field age as age, power as power, and nemesis as nemesis. So what we're trying to do is break these out into a smaller data frame with columns for each of the details. So now we have a 3x5 DF with the soup string, name string, age I64, power string, and nemesis string. So it took the struct, accessed each field, and made it a column for each one of those. The quick way to do it for all of them is unnesting. So I could just say result equals df.unnest, pl.call details, which remembers this whole thing, and then print that result. And bam, it has unnested my dictionaries, and bam, it has unnested my structs, and I now have a data frame where I can use each of the details as its own column. You might encounter lists in a data frame, and so let me show you. Not much you could do. You might encounter lists in a data frame, something like this: df equals pl.dataframe names is a list of lists. So Paul, John, George, and Ringo, Mary, Mo, and Curly, Sabrina, Kelly, and Jill. And then if you want to have another column, they have to have the same number of uh, values. And when you add another column, they have to have the same number of values in each list. So 4 ages, 3 ages, and 3 ages. So this should make a data frame with names. So let's run that cell and then print the data frame. So I got a list of strings and names and a list of integer 64s and ages. They're lists of lists. So I want to see all this broken out. I say result equals df.explode. If it was just names, it would give me a column of all the names. So I made a list, names and ages. It'll explode both columns. And when I'll print result, and bam, explosion. A 10 by 2 data frame with name and age for everyone in my list of lists. So that's structs and lists in Polar's data frames. I hope you liked this video. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.